Find the vertical effective stress at a depth of 30 feet in pounds per square feet. In this problem, a 10-foot layer of sand is above a 40-foot layer of clay. The groundwater table is at the sand-clay interface, so the clay layer is 100% saturated. The vertical effective stress is equal to the effective unit weight times the height of the soil above the point of interest. If there are multiple layers of soil above the point of interest, the vertical effective stress is equal to the sum of the effective unit weights times the height of each soil layer. In this case, we sum up the sand layer and the clay layer. The effective unit weight of the sand is equal to 100 pounds per cubic feet. This is also equal to the total unit weight of the sand because the sand layer is above the groundwater table. The height of the sand layer is 10 feet, and the height of the clay layer above the point of interest is 20 feet. What we don't know is the unit weight of the clay layer. But we've been given a number of properties about the clay layer to help us determine its effective unit weight. The effective unit weight of a sample of soil beneath the groundwater table is equal to its total weight minus the unit weight of water. We know the unit weight of water, but we don't know the total unit weight of the clay layer. The total unit weight is equal to the total weight divided by the total volume, which we can determine from the properties. We set up our block diagram and write in 0 for the weight of air, and since the soil is saturated, we know the volume of air is also 0. Next, we look at the water content, which is defined as the weight of water divided by the weight of solid. Rearranging the equations, in this case, the weight of water will equal 0.37 times the weight of the solid. If we assume 100 pounds for the weight of the solid, the weight of the water would be 37 pounds, and the total weight of the sample is 137 pounds. Next, we solve for the volume. The volume of water is equal to the weight of water divided by the unit weight of water, or in this case, 37 pounds divided by 62.4 pounds per cubic feet, which gives us 0.593 cubic feet. The volume of solid is equal to the weight of solid divided by the unit weight of solid, where the unit weight of solid is equal to the unit weight of water times the specific gravity. In this case, 100 pounds divided by the quantity 62.4 pounds per cubic feet times 2.7, which gives us 0.593 cubic feet for the volume of solid, and a total volume of 1.186 cubic feet. Back to our total unit weight, we divide 137 pounds by 1.186 cubic feet and find that it's 115.5 pounds per cubic feet. Again, we assumed that the weight of the solid was 100 pounds, and from that assumption came our total volume and total weight. However, we could have assumed any positive value for the weight of the solid and still come up with the same 115.5 pounds per cubic feet for a total unit weight of the sample. Back to our equations. We can now solve for the effective unit weight of the clay layer by subtracting 115.5 minus 62.4, which is 53.1 pounds per cubic. Plug that value into our equation for the vertical effective stress, and we find that the vertical effective stress at a depth of 30 feet is 2,062 pounds per square feet. Compared to our initial solutions, the answer is C.